Okay, so as promised, we have another round. The complexity gets a little bit more involved in this these next 5 examples, but again, the idea is you see a rule, you use a rule, all right, and you're going to be clear by what rules you're saying by showing me your work. All right, so let's tackle these. In the first one, taking a look at this overall, right, what I have is a quotient, and it's being raised to a power. All right, and so the first rule that comes to mind is our power of a quotient. So the power of the quotient tells us that we can take the power and make it hit the top. So we get x to the 5th to the 3rd power, and we get y squared to the 3rd power. So again, that's telling me that you are correctly seeing the power of a quotient rule. So please show me that step. Of course, now that we have that written, I now see this guy, right? I have a power of a power, an exponent of an exponent. So under those conditions, we multiply my exponents. So 5 times 3 and 2 times 3 on the bottom. And that gives us a final answer. We have x to the 15th and y to the 6th downstairs. All right, so again, nice steps. You're seeing the rule. You're showing me you know the rule by executing the rule. All right, and you're simplifying our expression. So we had to start with the power of a quotient and then a power of a power. The next one, we have a little bit of a mix. We have some things in parentheses and things not in parentheses. And so we're going to have to be very careful about who's who here. All right, so for starters, on the front end here, make sure you understand that that 2 only applies to the x. Right, so this 2 does not apply to the 3. So if it did, it'd be in parentheses, like this one. Right, notice 3x is in parentheses, so I have a product, and it is being raised to the 2nd power. So the product rule, right, so this guy stays the same, and the product rule says that 3 gets raised to the 2nd power, and x gets raised to the 2nd power. Right, and so I just saw, or I just used my power of a product rule. Now what we can do, right, is we can see we have some bases that are the same. Let me do one preliminary step and kind of rearrange the terms, or excuse me, rearrange the factors. So using the commutative property, I can basically flip-flop these two. And the reason I did that is because we basically now see my product rule. Same base, so we're going to keep the base and add the exponents. Same base, so we're going to keep it and add the exponents. Again, you're showing me there with that step that you see the rule and you're using the rule. And then of course 3 to the 3rd, or excuse me, 3 to the 1 plus 2 is 3 to the 3rd, and x to the 2 plus 2 is x to the 4th. I'm satisfied with you leaving the answer that way, but I'm pretty sure on my math lab and whatnot, 3 to the 3rd, they'll probably want you to write as 27. But on a quiz, when you're submitting those, if you want to leave your answer that way, I'm A-okay, because I'm more worried about you seeing the rules of exponents, and you did a pretty good job doing it in that example. So the next problem, right? So in the next one, we have a lot going on. But again, what I initially see at the very beginning, right, is I see a quotient being raised to a power. So there's my power of a quotient. So I see this as we're going to take the top and raise it to the 2nd power, and we're going to take the bottom and raise it to the 2nd power. So that's what that rule says. Both the numerator and the denominator get hit by that power. Now what I see is an opportunity to use the power of a product. Here's a product and it's being squared. So the 9 is being hit by that power, and x to the 4th is being hit by that power. Down in the numerator, the 6 is being hit by that power, and the x is being hit by that power. So I just used my product rule, excuse me, my power of a product rule up in the numerator and denominator. And now we can just start cleaning things up. So, you know, again, 9 squared is 81. X to the 4th to raise the 2nd power is that rule. So I have x to the 4 times 2. And 6 squared is 36. And we just have x squared down below. Right? And then slowly but surely what we have is 81. Right? X to the 6th all over 36, x squared. All right, and believe it or not, we're still not done. For starters, there's 2 fractions here, right? There's the fraction 81 over 36, and there's the fraction x to the 6 over x squared. So here's the opportunity to use the quotient rule, and here we're just simplifying. I believe 9 goes into both these, right? 9 goes into there 4 times, and 9 goes into there 9 times. So we have the fraction 9 over 4. So finally, cleaning this up, right, there is finally the final answer by using our rules. That one was on steroids because we used power of a quotient. We end up using the power of a product. We end up using the exponent of an exponent. And we ended up using the quotient rule. So on steroids. However, what I like about this guy is there's actually another way we could have done this, right? I started this by seeing it as a quotient raised to a power. But what if we were to use the order of operations and think about what's happening in the parentheses first? When I do that, right, I have an opportunity in the parentheses. Let me kind of write those as the two fractions that they are, right? And it's still squared. But here I can kind of see that 3 goes into there twice, and 3 goes in there 3 times, and that's an opportunity to use my quotient rule. So I basically have 3, right, over 2, and this is x to the 4 minus 1. So we basically have 3 halves, x to the 3rd. Now, of course, all of this is still being raised to the 2nd power, so I haven't done that yet. So essentially, what I have, right, is I've started this problem differently by simplifying, using my quotient rule and using just our simplification of fractions. I've simplified it. And when you look at this, I now have a combination. I have a quotient and I have a product. So using both these rules, that means everybody, right, 3 gets squared, 2 gets squared, and x cubed gets squared. So everybody gets hit because of the power of a quotient and the power of a product. And then what ends up happening is 3 squared we know to be 9, 2 squared we know to be 4. Here we're multiplying my exponents, right? We're using the power of a power, and lo and behold, you end up with the same exact answer. All right? So there you go. All right? As a matter of fact, you know what? I think I made a mistake. That should be 8, and that should be 8, that should be 8, and turning that to a 6. So you just saw your math instructor make a mistake. All right? If we were in a classroom, you guys probably would have caught that earlier and would have stopped me. All right? But now our answers are the same. 9/4 x to the 6. All right? So showing my work along the way. Again, via I see a rule and I'm showing how I use the rule. Keeping in our line, number 4, we have a lot of parentheses. I have products being raised to powers, so I'm basically going to be using this twice. So I have a cubed to the 2nd power and b to the 2nd power. Here I have a to the 4th power and b to the 4th power. Here I have an opportunity to use my power of a power. And so we end up with a to the 6, b squared, a to the 4th, and b to the 4th. All right, and now we can rearrange this if you want. Let me rearrange things so some terms, oops, that's a 2, right? And so this is our product rule. So we add my exponents, and we add my exponents. So we end up with a to the 10th and b to the 6th as our final answer. All right, so that one was pretty wild. We started off with the product rule a couple times, ended up using the power of a power rule, and then rearranged and was able to use our product rule. Last one, right? It's getting a little messy here. So first thing I see, right, is I have an exponent being applied to the top. Now this problem is a little bit different than this one because, yeah, 2 and 10 share a common factor, but here the 9 and the 6 were within the same set of parentheses. Here they're not. So we actually, again, order of operations, before I do any division, I have to do exponents first. So be careful. So what rule do I see? My power of a product. So we get 2 to the 4th, right, x to the 4th, and then we just have 10, x to the 4th on the bottom. Breaking this up into the 2 fractions, 2 to the 4th, well, that's 16 over 10, and this is x to the 4th over x to the fourth. This is simply reducing a fraction. I believe the common factor is 2. So 2 goes into there 5 times and goes in there 8 times. So we have 8 over 5. And here what I have, right, if you want to be official, is I have my quotient rule. And we end up with 8 to the 5th, x to the 0. Of course, what is anything to the 0 power? It is 1. Anything to multiply to 1 is just itself. And so that's how the number 5 will simplify. So there's some more complicated ones there, but hopefully you see me exercising the idea of seeing a rule, use a rule. Please show me your work. That way I know you're actually seeing the rules that I'm trying to teach you. Okay? This isn't a Math 150 class where I can let those slide. Since you're learning the skill, I need to see the skill. Deal? All right, so that should wrap up our 4.1. We're going to move into 4.2, where we'll still talk about exponents, but they're going to be negative. So I'll see you in the next section, in the next round of videos.